All right, so on example 8, we had on 2 examples ago, we had a position equation, then we had a position graph, and now we're going to have a velocity graph. So in one sense, it's the same. It's a graph. But in another sense, we have to read it differently to get sometimes the same information. And then there are some things that we actually can't answer just yet. So the graph above shows the velocity now, v of t of a particle in feet per second, moving, we're back along a horizontal line from 0 to 6. So if it hadn't had this done already, I would label the axes. So you got feet per second on the y-axis, seconds on the x-axis. And then very quickly just kind of make sense of what's going on here. The y values are, of course, the velocities. But now the slopes represent what? The accelerations. The slopes are the accelerations. And it's going to turn out when we get to the second half of calculus, the area under the curve is going to end up being something as well. But we're not going to touch on that yet. Distances. All right, we touched on it. Very good. On what open intervals or at what times from open interval 0 to 6 is the particle at rest? Particle is at rest when what? What are we looking for here? What's our... It's when the velocity is 0. Okay, well, we have the graph of velocity, so there's definitely a time at 1 where the velocity is 0. And then there's another spot right there, which looks like it's at 4.127, right? Anyone disagree with that? 4.127. Okay, so here's what we have to do. We need that x value. We don't want to assume. So there are calculus questions on the AP exam where they have it cross at a non-exact point, and you have to find it. So it's kind of a problem within a problem. If we can write the equation of that line segment, we could then find its x-intercept. Yeah? All right, so we need a point in the slope. I think I'm going to use the point 5,4 as my point. You could also use the point 3, -6. And then let's calculate the slope informally. We go up from -6 all the way to 4. So that's up 10. And then we go right from 3 to 5. That's 2. So the slope should be what? Up 10, right 2 is 10 halves, which is 5. So the equation of the line segment in Taylor form is y equals 4 plus 5 times x minus 5. And now I set it equal to 0 to find its x-intercept. And notice I'm doing this off to the side. So let's just distribute that. 5x minus 25 equals 0, with the plus 4 there. So it's going to give me a -21, which when I bring it across is positive 21. And I get x equals 21/5, which is also known as 4.2 for whatever it's worth. Okay? So I'll write it as 4.2, but you can leave it certainly as 21/5. And so now I'm ready to answer the question. The particle is at rest at t equals 1 and 4.2. At t equals 1 second and t equals 4.2 seconds. Because those are part of our answers, we want to make sure we put units. And then you could justify by saying since at these times, and that's a judicious use of a pronoun, the antecedents are clearly defined, since at these times, comma, v of t equals 0. Or you could say since v of 2 equals 0 and v of 4.2 equals 0. Either way, right? They both kind of say the same thing. So this right up here, I'll put it in parentheses. That's just us mentally thinking, okay? Comments or questions on that one? Letter B. On what open intervals is the particle moving to the right? Justify. Well, the particle is going to be moving to the right when my velocity is what? Positive, right? So I want to know where v is greater than 0. That's going to be above the t-axis. So from 0 to 1 and 4.2 to 6. Now it does say open intervals, right? Had it not said that, would we include t equals 0? Is the velocity positive at 0? It actually is. Yeah, we saw that the other day too. But it's at open intervals, so we'll just say from 0 to 1. So velocity, or actually answering it this way, sorry. If it's only asking where is the particle moving to the right, you don't have to write that complete sentence. You could just say on the interval from 0 to whatever, 1 and 4.2 to 6. 0 to 1, union 4.2 to 6. Make sure you put units, and you can say since V of t is greater than 0 on this interval, on these intervals, yeah, that'll work better because there's two of them on these intervals. So if they were asking for like more than one thing on this particular part, we would need to make sure we write in a complete sentence. What would that look like? Well, it could easily say on part B, it could say on what open intervals is the particle moving to the right? Question mark. Left? Question mark. Right? Now you couldn't just list an interval, right? Because, or correct, I should say, because you're not saying if that's when it's moving left or right. But in this case, they're only asking one thing. So we're not at risk of confusing things here, okay? Part C, on what open intervals or at what time is the particle moving at its greatest speed? And here's what I meant, greatest velocity. So now we have two things, we need to label them, greatest speed, it didn't say to justify, and then greatest velocity. All right, so for greatest speed, what are we looking for here? How is speed related to velocity? Yeah, it's the absolute value of it. So if you want to sketch the absolute value function, remember the transformation would be to leave positive values alone and then reflect it across all negative values reflect across the x-axis. And it would look like that. And of course the positives would stay the same. And now you're looking at the speed function, or you don't even need to graph it, right? For speed, you just want it to be the farthest away from the t-axis in any direction. So on the positive side, the farthest away we get is 4 units. On the negative side, we get as far as 6 units away, right? So without having to graph it, just know that speed is non-directional. It looks then like it's at t equals 3. All right, so the greatest speed, I'm going to go ahead and say I'm going to add more information, is 6 feet per second at t equals 3 seconds. And the greatest velocity, well, now the sign matters. For greatest velocity, we either want the most positive, or if there are no positive y values, we want the least negative. So where does that happen? Initially, right, it's 4, and from 5 to 6, it's also 4. So we have more than one time. Now it does say on the open intervals, so that excludes the starting position, and it excludes the ending position, right? So it would just be then from 5 to 6, based upon what it says. So the greatest velocity is 4 feet per second on the interval t epsilon 5 to 6 seconds. Okay. So that's important right there, open intervals. Had that not been there, we would have had to include 0 and the right endpoint. All right, questions on that. Speed farthest away on either side and velocity. That right there is like one multiple choice question. I'm thinking right now of a multiple choice question from long ago where it had something like this, and then it went way down here, and it was A, B, C, D, and E. And the question just said, at what value of t is the speed the greatest? And of course, the answer to that is what? D, right? Speed is the greatest at D. If it said, at what value of t is the velocity the greatest? It would be B, right? If it said, at what value of time is the velocity portrayed in eggplant? Purple. That would be on the closed interval from A to B. Very good. Yeah. You won't have that question. Sweet. So there's a free one, we'll say, on the AP exam. On what open intervals from 0 to 6 is the particle speed increasing? Oh, and then decreasing. So speed is increasing when velocity is less than 0 and acceleration is less than 0, or when velocity is greater than 0 and acceleration is greater than 0. So velocities are the y values. So what are the accelerations? The slopes. So here's another way to do it. For the slopes to be negative, you could say v is less than 0 and decreasing. or velocity is positive and increasing. And that's another way to justify it. Now, if you have the graph of velocity, there's a real easy way to tell. Okay, but I wouldn't justify it this way. For velocity graph, if the graph moves away from the t-axis, speed is what? Increasing in any direction. But if the graph moves towards the t-axis, the speed is decreasing. We have given credit. We, being the College Board readers, I had a paper that justified this way. It's not how they like it, but I looked into it, and they actually took credit. They gave credit when you have the graph of V. So now you can easily tell, right? Where's the graph moving away from? Let me unhighlight it. The graph is moving away from 1 to 2, and from 2 to 3, and from 4.2 to 5. See that? So on those three intervals, since the graph is moving away, the speed should be what? Increasing. I'm going to write the answers here and then paste them down below. So speed is, and we have to label it here because it asks us for increasing and decreasing, the same question. Speed is increasing on the intervals, open intervals, from 1 to 2, union 2 to 3, or can I just go straight from 1 to 3? What do y'all think? Can I just go from 1 to 3, or do I have to step over 2? We're talking about the slopes as well, right? The accelerations are the slopes. What do we know about the slope of this graph at 2? Yeah, does it change at a smooth rate, or does it abruptly change? It abruptly changes. So that's a cusp. It's not the most jagged cusp you'll ever see, but it is a cusp. So are the slopes defined there? Is the derivative defined there? No. So you have to step over it. The velocities are defined there, but the accelerations are not. So you do have to step over it. So from 1 to 2, from 2 to 3, and then union 4.2 to 5. And then you could say, since the graph of V of t, don't just say the graph of V of t moves away from the t-axis on these intervals, okay, now if you didn't do that, you would actually have to justify them kind of separately, since on the interval from 1 to 2 and 2 to 3, velocity is negative and decreasing, and on the interval from 4.2 to 5, velocity is positive and increasing, because they're doing different things. But if you just say on these intervals, the graph of V is moving away from the t-axis, that is acceptable, okay? So it's a little bit different than if you would have the equation. If you had the equation, then you would do it like we did on the quiz, where you'd actually just compute the values, because it's a little bit easier, all right? And let's go ahead and answer the other question. When is the speed decreasing? Well, that's going to be when the graph is moving toward the t-axis, right? Because that's when your velocity is approaching 0. So we'll say speed is decreasing. Speed is decreasing on the interval t epsilon, open intervals it said. So from 0 to 1, and then union 3 to 4.2 seconds, comma, since on these intervals, the graph of V of t, not just the graph of V of t moves what? Towards the t-axis. And again, if you didn't do that, you'd have to justify both of them separately. It would look like this. On the interval from 0 to 1, since on this interval V of t is positive and decreasing, And again, on the interval from 3 to 4.2, since v of t is negative and increasing on that interval. So that would be, the acceleration would be the opposite sign. All right, so it's okay to do it. I'm fine with y'all doing it like that from the graph. Perfectly fine. I know for a fact that they do accept it on the AP exam, and I actually kind of like that. It's a slicker argument. It's a little bit swifter. Now, before I walk away, when I did something over here, I was questioning whether I did it on the previous one. See that unit right there of seconds? I don't remember writing it on the first one, so I had this little moment. So I'm going to come back and write it there before I walk away, which you should always kind of do. Just kind of make sure that everything looks good before you walk away. Interval notation. I like interval notation. They give you inequality notation up here. Feel free to use that, but I think interval notation is just a little slicker. Now, what if I didn't put T epsilon? Do you think they'd still take it? They actually would, yeah. When you list an interval, it's implied to be the independent variable, but you know what? I kind of like having it there because it's indubitably now the independent variable, okay? So it's nice to have there. It's kind of the same reason that in the inequality, you do have to have the variable there. Otherwise, it looks funny having just a space, right? Okay, what's the particle's acceleration at 4.8? Acceleration at 4.8, so let's go find 4.8. It is right here. How are we going to find the acceleration there? It's the what of this graph? The slope. Good. Did we already find the slope of this graph? Yes, we did it off to the side. I didn't really do it in part A. I didn't really do it in part B. Does it ask us to justify how we found it? No. So I'm just going to say V prime of 4.8, and then I'm going to label that as A of 4.8. So now, by defining it as A, I can use the letter A to mean acceleration anytime I want. I'm going to say 5, and then what would the units be? Feet per second squared. Yeah, I know a lot of y'all are physics-minded. We don't use meters in here typically, so if you wrote meters per second squared there, it would actually be wrong. I hate to say that. Even on a question, let's say this is a free response question, sometimes they make the units worth 1 check total. Sometimes they tie the units to the right answer. And then sometimes, believe it or not, but very rarely, they don't even count the units. So let's say this was one of those rare times where they didn't even count the units. So if you had them there, you didn't have them there, you wouldn't lose points. But let's say you did your thorough and you put meters per second squared. If they weren't even counting units as a check, would you lose points for that? Yes, you would. Because now you've misspoken. You've essentially said too much and you said it incorrectly. So I know it's an old habit to break. Meters, right? We're one of the few nations in the world that uses a standard. But we do use them typically. So when in doubt, just look back up here and do a double check, right? All right, explain what it means in terms of the particle's velocity, all right? So like we did on the quiz, I asked you to explain it in terms of the position. Here it's asking you to explain it in terms of velocity instead of just saying the particle's acceleration is 5 feet per second squared. Acceleration is the rate of change of velocity. So if your velocity is positive, if your acceleration is positive, velocity is what? Increasing. So here's the sentence. At t equals 4.8 seconds, comma, and you don't have to say the particle's velocity. You could just say the velocity is increasing by, and now because we're talking about a change in velocity, we need to answer it in velocity units. So by 5 feet per second, and then separately we write per second or each second or every second, okay? And before you walk away, you make sure you have units on your independent variable, which is seconds, and on your dependent variable, which is 5 feet per second, and we do, okay? If you do the sentence perfectly, but you just leave off the seconds on the original part, it's only worth 1 check. You'll lose the check, all right? And we don't want that to happen. So Just be very, very unit conscious. All right? Any questions on that? So good so far? On what open intervals or at what times from 0 to 6 open is the acceleration the greatest? All right? So now we're looking for where the graph is just in general the steepest in any direction? Right, the most positive. As far as I know, there is no speed equivalent to acceleration like there is for velocity. Like we have velocity where sign matters and speed where it doesn't. It's just the scalar. For acceleration, what do you call just the scalar magnitude of acceleration in the non-direction? I don't know if it has a name. But when it says for the acceleration being the greatest, it's either the most positive or the least negative. So even if you had something that was super, super steep in the negative direction and then just barely positive, the acceleration is going to be the greatest on that interval there. Because any positive number is greater than a negative number, yes? All right, so there's only one interval here where the acceleration is even positive, right? And that's from 3 to 5. That's where the graph is increasing. So we don't even need to compute it. So that would be from 3 to 5, 3 to 5, 3 to 5. And because it's the only question they're asking here, we could just say for t epsilon, 3 to 5 seconds. Does it ask us to justify or explain anything? No. So that's all we'd have to put there. That's it. And then part G. G is for genius. By the way, on the worksheet, there will be a couple of times where the last part of a free response will say genius question. That doesn't mean it's bonus. That doesn't mean it's optional. That just means it's written for you guys. Okay? Those are the ones, that I want y'all to do. Because that's kind of where they stretch you a little bit. It's an extension of something that maybe we haven't talked about yet, or there's more steps involved, or it's three-dimensional instead of two. So that's what they're there for. Of course, I'm not taking in the worksheets this year, so I can't see if you did that or not did that. But what is the particle's displacement during the 2 seconds? I have a word missing there, obviously. I meant to put during the first 2 seconds. So that would be from t equals what to what? 0 to 2. Yeah. What is the displacement? All right. So I said we weren't going to touch on it, and then we touched on it. So I guess it's time to touch on it again. Remember that the derivative is what process, essentially? Leibniz notation, right? dy dx. What does that bar mean? Division, right? Division. So if you ever want to know what the units of the derivative are, just take the units of y, which in this case are feet per second, and divide it by seconds. And of course you get feet per second squared. Or turn that around, if you ever know that you need to come up with units of feet per second squared and you're not sure what to do, if the derivative gives you feet per second squared, you're probably going to have to take the derivative. What would happen if I multiplied instead of divided my units? What would feet per second times second give us? It would give us feet. And that's unit of length, right? So what do we call that? If we're not dividing but multiplying, we get what's called not the derivative but the integral. It's the second half of the house of calculus, and it looks like this. It's the integral with respect to dx, and we have, oops, let me put a function in there. We have the integral of some function of x, f of x, times dx. And so we have multiplication. All right, so yes, it's true then that if you find the area of the regions, you're finding the net change in position. And sign matters, right? So as we go from left to right, any area above, bless you, is going to be positive, right? We know that because from 0 to the 1, the particle's moving in the positive direction to the right. So let's go ahead and calculate the area of that region. It's a triangular what shape? Triangle, good, a triangular triangle. The area is 1/2 base times height. The base from 0 to 1 is 1. The height is 4. So that area is what? 2. Now here's what we're going to do. Remember how we showed the slope kind of in the graph? When you find an area of the region, you're going to want to write it inside the region. And I usually circle it just so it stands out. So that means in the first second, as the particle is moving to the right, it's traveling 2 feet in that direction. By symmetry, this one is also 2 feet. So from 1 to 2, the particle is moving 2 feet now to the left in the negative direction. So the total distance traveled would be 4, yes? But what's the displacement? 0, okay? So for the genius question, all you have to do is say 2 minus 2 equals 0 feet. Why 2 minus 2 instead of 10 minus 10? They are referring to these values that you have written in the regions, okay? And sign matters. Just like for the derivative, it's a vector. Velocity is a vector. So is the integral. The sign matters. From left to right, above is positive, below is negative. So that's what we're doing in the second half, all right? So we finished example 8. Tomorrow we'll finish example 9, and we're going to roll right into the next section, which is the chain rule. We don't have time to kind of spend 30 minutes doing nothing. All right? Have a super duper rest of the day. Remember, there's a football game tonight on a Thursday at 7 o'clock against Judson. So all spirit groups, band, everybody, hope to see you all there. Drive carefully.